Okay, good evening. Okay, this is Professor David J. De Los Reyes. Okay, my topic for tonight will be a continuation of my long video format topic AC machines, and I am now on lesson number 52. I think this will be the last topic on transformer because the next time around I will start discussing alternators, power generation. Okay, let's proceed. The title of the topic for tonight will be AC Machines, lesson number 52. We are running smooth, okay? We are almost done with the transformer. The title of the topic for tonight will be example problem on auto transformer. Okay, I will try to give you an example problem regarding computations involving auto transformer. The last time around, I brought out the equations needed in the computations by presenting the derivation, and I give you the equations on how to compute the required things under auto transformer. Okay, I will try to read the problem. An auto transformer is used to step down the primary voltage V1 to 0.65 V1. If V1 is equal to 240 volts and 200 amperes at unity power factor is supplied by the secondary, determine how many unknowns over here. There are 5 unknowns. The voltage across BC, the current across AB, the current across CB, capital letter PT meaning power transform of the given auto transformer, capital letter P and C meaning power conducted by the given auto transformer. So to visualize the verbal equivalence of this, we shall try to look at the what we call this equivalent of this in terms of a figure. We are given an auto transformer. This should be the primary winding AC, secondary winding BC. Across BC, we are a load Z sub L is actually connected. Z sub L, impedance load. The current consumption of this load is 200 amperes. Power factor is 1. So meaning to say the current coming out here is 200 amperes. Okay. In according to the given condition of the problem, the input voltage V sub 1, which is equal to 240 volts, will be stepped down. Okay, step down. Meaning to say, we'll be transforming this V sub 1 to a value 0.65 V sub 1. So meaning to say, this stopping here is 65%. Auto transformer is a transformer in which there is only one winding, and the secondary winding is just a percentage of the primary winding. So if this is 100%, according to the given problem, the voltage across this will just be simply 0.65 V1. So this is actually step down. Okay, step down. The problem is asking what will be the voltage across BC. This is terminal A, terminal B, and terminal C. The problem is asking what will be the voltage across BC. The current passing through the terminal AB. We are given the markings, right? So we are asked the current passing here. Okay? The current passing through CV, the current ICV. from C to B, what will be the current? Okay. And letter D, since there are only two powers involving autotransformer, it is the so-called power transformed and power conducted. The problem is asking for PT, the power transformed, okay, and the power conducted. So this is just a simple problem if we could visualize the given verbal equivalent to a circuit figure. Okay, let's try to bring out the solution. We are to solve the voltage across BC, across this. Okay? And if we try to inspect the voltage across BC, this is B sub BC. The voltage across this. Right? The voltage across BC should be equal to B2. B2 is the output voltage. So if we know B2, we could compute for B sub BC. So I place it here, the voltage across terminal BC is actually equal to the voltage of the output or the secondary. And according to the given problem, the original 240 volts is reduced to 65% or 0.65 of P1. That's the value of B2. And this B2 here is actually B sub BC. So since B sub BC is B sub BC is B sub 2, B sub BC is B sub 2, and B sub 2 is actually equal to 0.65 V1. That is a given condition. It's only 65%. It's just a 65% percentage of the overall 100. So this should be 65 times 240. And the voltage across BC will be 156 volts. So meaning to say, if this is 240, the voltage across the secondary, which comprises only 65% of the total 100%, is equal to 156 volts. So this is 240 and this is only 156. Right? It was a step down from a 240 to 0.65 V1, or that is 156 volts. Letter B. Letter B is the current through AB, the current passing here from point A to point B. If we try to look at the given figure, the current circulating on the left loop is I1, right? Okay. If we try to speak it, I1 is this one here, right? And it passes here. That's I1. That's I1. That's I1. So I1 is actually I of AB. Okay, so I place it here, I sub AB is actually equal to I1, and we can actually compute for I1. But before computing for I1, let's try to compute first the so-called ratio transformation for the given transformer. The input voltage is 240, the output is 156. Okay, there is a transformation ratio over there, it's step down. So A is actually B1, the input voltage, over the output voltage. This is for step down, right? So for this auto transformer, we could compute for the ratio transformation. That will be 240 over 156, and this is 1.538. Why did we compute for A? We compute for A because in the computation of the current, we needed the ratio transformation. Because in the computation of the current, we will be using another formula involving ratio transformation. For a step-down transformer, ratio transformation will be the bigger current over the smaller current, right? And I1 here is the one we are looking for. So if we try to compute for I sub 1, I sub 1 will be I sub 2 over A. It's from this, right? What is I sub 2? Are we given I sub 2? I think we are given I sub 2. I sub 2 is actually 200 amperes. Right? The one coming out here is I sub 2. Okay? It goes down here. Right? So whatever current passing here will be same as this one, But we know that the current passing through the load is 200 amperes, therefore I sub 2 is 200 amperes. Right? So if we now try to compute for I sub 1 now will be 200. We know I sub 2, it's the output load current, right? 200 over 1.538. Therefore, the current passing through, or I sub 1 now, which is actually equal to IAB, okay? And this should be equal to, what will be the value? 200 over 1.538 is 130 amperes. IAB is actually equal to I1. Right? We are asked to compute for this one, but this one here is equivalent to this according to this formula. Therefore, IAB will be 130 amperes. So this is 130 amperes. Okay, that's 130 amperes. Okay, I will try to erase this one also so we could visualize the current later. Right? Letter C. The problem is asking for the current from terminal C to B. It is this one here, I sub CB. Right? So considering this junction here, we know the current entering here is 130. It's 130. The current going out is this is 130. This is equal to 200 amperes, right? And we are asked for the current I sub CB. So it's just a summation of current considering this junction here. The current going out is 200 amperes, and this should be equal to the current going in. The current going in is this one here plus this. The current going out is this. So if we try to formulate our equation, okay, I sub 2 should be equal to I sub CB plus I sub AB. Okay, and if we try to compute for I sub CB, algebra, right? I sub CB will be I sub 2 minus I sub AB. We know I sub 2 to be 200 amperes. I sub AB is 130. And here, we are not adding this one, what you call this, vectorially. It's just plain algebra, right? So this should be 200 minus 130. Okay? So 70 amperes. So current I sub CB should be 70 amperes. 70 plus 130 is actually equal to 200. Okay? Letter D, the power transform. The last time around, I derived the formula on how to compute for the power transform considering autotransformer. So power transform, capital letter P and P will be the product B1 I1 times the quantity 1 minus 1 over A. B1 I1 is actually power input. The product of the total current coming in and the voltage across this is the total input power. And if we try to multiply this by the quantity 1 minus 1 over A, we derived this one the last time around. We call this one power transform. We know B sub 1, we know I sub 1, we know A. Direct substitution. 240 times 130 times quantity 1 minus 1 over 1.538. 31,200 times 0.3498. 1 minus this is less than 1. So it should be 0.3498 times 31,200. So the power transformed by the given autotransformer is 10,914 watts. Okay. Don't ask me why we use this one. We derived this one the last time around. And we are asked the power transform. So to compute for the power transform, we must use this. For the power conducted, again, the last time around, we derive again this one. It's power conducted is actually B1 I1 times 1 over A. And the product of B1I1 is still power input. Okay? But the formula on how to compute for the power conducted is different. We derived this one the last time around. So power conducted by the given autotransformer will be the product I1 B1 I1 is 31,200 times the quantity 1 over 1.538. This is less than 1. So we multiply this by this. What comes out is 20,286 watts. This is actually the power output of the autotransformer. Right? So meaning to say, we applied 31,200 there. What comes out here is 20,286 for the given problem. Right? It should be less than. Okay? This is the power input, 31,200. What comes out, power conducted will be 20,286 watts. Okay, that's it guys. That's how we compute currents and voltages involving autotransformer. Okay, it's an easy one. As soon as you read the problem, try to figure out, put the markings. So in the so-called formulation of the current formulas, try to bring out a certain node over there so you can formulate this one. Okay, this one was derived from this node here. Current going out is current entering. It's this. Okay. That's an example problem involving autotransformer. Okay, this is Professor David J. De Los Reyes. Good evening from Los Angeles.